Okay, Paul, we're going to start right off without any introduction from me. Can you briefly describe your nuclear qualifications?
Yeah, I'm going to try to keep everything as brief as possible, but need to go back quite a ways. And, I graduated from high school in 1959 after almost flunking out. And then I joined the Navy in 1964 to assure that I didn't go over to Vietnam. In the Navy, after boot camp, I went to electronics technician school, and that was about a year. Then I went to nuclear power school. That was another year. From there, I was an instructor in reactor theory and operations. That was for 2 years. And then after I got out of the Navy in 1970, I went to college and got my engineering degree. And in all those classes, I was near the top of my class. Graduating in 1972, I joined Northeast Utilities. It had 5 nuclear operating power plants, not unlike Southern Cal Edison, probably a little bit smaller. Worked at Northeast Utilities from engineer all the way up to engineering supervisor, and responsible for reactor safety and safety systems and instrumentation control and piping systems and regulations and so on and so forth. And at the time, I thought that the Nuclear Regulatory Commission was a very tough regulator and instilled the fear of God in all of us regulatees. 1989, I was working for the Electric Power Research Institute out in Palo Alto, California, and discovered some data that impacted all nuclear power plants in the world. And this is 1988, 89. And I was scared at the time that if we ever divulged this, it would shut down all nuclear power plants in the US at least, because it was very significant. I worked with the Nuclear Energy Institute to try to resolve this. That didn't go very far. And then I went to the NRC and my management and said, you got to fix this problem. And you can imagine what happened when one brings forth a safety issue that's going to cost money. The world came down on me. I mean, you talk about harassment, intimidation, threats, and everything else, like any whistleblower, and there's hundreds of them, even inside the NRC. Well, my company came down on me very hard and, threatened to fire me and so on and so forth. And even though it was against NRC regulations, the NRC would not do anything about it. I continued working with the NRC in the Office of Investigations. They eventually did an investigation, and out of about 1,000 investigations, I was only 1 out of 1,000 that my allegations of harassment and intimidation were validated. And they fined and really sent a lesson to Northeast Utilities, a $4 billion company, and fined them $100,000 like a traffic ticket. From there, it was obviously uncomfortable for me and for my employer, Northeast Utilities. So we worked out a settlement agreement that I would never return to work for Northeast Utilities, and I left. Continued, we then made the cover of Time magazine, and the entire management chain of Northeast Utilities, from the chairman of the board down to my supervisor, were dismissed. I then embarked on going public and helping out other whistleblowers and helping them go through the court system and so on and so forth, but also got engaged again in lecturing on safety culture to every chief nuclear officer in the country through the Nuclear Energy Institute. And even though my agreement with Northeast Utilities said I would never return. I was rehired as a consultant in 1997 to assist them in reestablishing their safety culture and whistleblower problems. That lasted for 4 years, it was only supposed to last for a few months. From there, I went to Indian Point, again, on safety culture and whistleblower issues, then to Maine Yankee, same topic. And then continued to start some of my interface with the NRC and their failure to enforce the regulations. And I've done a lot of work, thousands of hours on that. So that pretty much summarizes it without getting personal.
Thanks, Paul. I learned a lot. I thought I knew everything about you, but that's wonderful. Okay, next one. You have stated that the buildup and disposal of nuclear waste from nuclear power plants is the biggest threat to humanity next to climate change. Can you explain why?
Well, it is. With climate change is very serious. And you know that. You see the results out in California. We see it down in the North and South Poles. We're seeing flooding, hurricanes, snowstorms, and so on and so forth. It is probably the biggest problem. Now, you could take in, the Department of Defense and all their nuclear weapons, but I'm not going to say that's a different topic. But as far as the impact on the world, and we have nuclear power plants all over the world. And while their operation, we have Fukushima that caused a lot of relocation and harm and deaths and so on and so forth, and Chernobyl. But the real problem we're facing now is the 100,000 tons of nuclear waste that is essentially stored at all these various sites. And it has a finite probability of causing an accident that could be devastating to the surrounding area. And I say that especially as it relates to the San Onofre nuclear power plants because of their proximity to the ocean and the potential for flooding. I can't think of any other industry or problem this environment is facing other than nuclear fuel and global warming. At least with global warming, we have a way we can correct that by reducing our carbon emissions, but we don't have a way to deal with the nuclear waste. I don't even have an idea as to how to deal with it.
Thank you. So on to San Onofre. What do you see as the most significant risk there?
There are many issues, but the one that stands out is the flooding issue. And we've actually seen pictures, and I'll be presenting them in another presentation, that projects flooding, not from a tsunami, but from a storm of the very area where the spent fuel is stored. It's a sworn legal document submitted to the NRC and says that area will flood. And this was submitted before there was fuel located there, but when they decided to locate the fuel there, they apparently redid their accident analysis and said, oh, it can't flood there. But believe me, you've seen all the studies that say there is a probability that these will flood. And that's why I think the storage of spent fuel is the second biggest problem the world is facing.
Okay. So in January of 2020, you and the organization Public Watchdogs filed a formal petition to the NRC called a 2.206 petition on San Onofre nuclear waste, temporary storage canisters, and flooding tsunami concerns. You declared the need for a risk assessment. This wasn't carried out by the NRC, the Nuclear Regulatory Commission. The NRC's response was that the loss of integrity of a canister resulting from conditions of tsunami, flooding, or really anything is not credible. They also offered Holtec canister licensing documents with redacted information as pertaining to flooding and tsunami. Can you explain why this is a huge problem?
Well, first of all, when they say it's not credible, and I asked them to define what is not credible, they refuse to provide me an answer because it's not defined. We don't know whether it's 1 in a million chance, 1 in 1,000 chance, but we know it is credible because they are designed, they have to be designed for flooding. And if you look at the consequences for flooding, they are potentially very, very significant. In their response to the petition, which they didn't even accept as a petition, they said, we've already answered those questions. And they give me a reference and it doesn't answer the questions. Flooding is the most significant issue for San Onofre, and the Nuclear Regulatory Commission does not admit to the possibility. In fact, in licensing documents, they even state that flooding is not considered an accident. These are only, a few feet above sea level with global warming occurring and sea levels rising. It's going to happen sometime, and I wouldn't want to be around when it does happen.
Okay. That's sobering. Why doesn't the NRC or the manufacturers of the canisters at San Onofre have a risk assessment study which could show the public that canister integrity under any conditions, including flood and tsunami, is not credible?
Well, this gets back to the old Atomic Energy Commission and Department of Energy, and we know how they've operated in the past and not putting out all the information. You had a reactor right there in California, what was it?
Santa Susana.
Yeah. And how long was it before you knew about that? The government, all these regulatory agencies, manufacturers, will not put out complete and factual information about the risks. So they try to hide it. What would happen if the Nuclear Regulatory Commission or Holtec said, well, if there is a flood, this is what may occur? What would that do to public confidence and panic in the people in these areas? Now, my job is not to panic the people, it's to inform the people and let them make their own decision. There are some people that we know that are afraid of what might happen and actually moved out of the area because of that fear. And I believe that if the truth came out, there would be a lot of very, very concerned people, and that truth will come out during our presentation in May.
Okay. So we know that non-credible events frequently occur, such as 15 feet of snow, flooding, dam and levee failures in California, 3 Mile Island, Fukushima, East Palestine train wrecks, bridge failures, etc. What is the most significant potential nuclear event that would impact the residents of Southern California?
Okay, that risk, which I alluded to before, is a storm, a tsunami. We don't even know the probability of these events, but they will occur, and they will occur sometime in the future. I can't put a date on it. That will cause water to come over the top of these buried casks. When that occurs, and I say casks, right name is canisters. When the water comes in, it will flood these submerged canisters that are sitting there at close to 600 degrees and have been exposed to a corrosive marine environment. We do not know what this 50 or 60-degree water is going to do to the integrity of those canisters that are welded, and shocking them from 50 degrees or from 600 degrees down to 50 degrees, I believe would cause some type of a breach. Now, what would that breach do? It would cause water to come into the canister, surround the spent fuel. And this fact is not denied by, it's alluded to, but not denied by the manufacturer, that water covering that fuel, if it's not borated, which is a criticality preventer, that these devices, these canisters, could go critical. Now, going critical is the worst possible thing that could possibly happen. It happened at Chernobyl. It didn't happen at Fukushima or 3 Mile Island, but it happened at Chernobyl on a test reactor up in Idaho called SL1. If it goes critical, there is a need for evacuation, and we could have 73 criticalities simultaneously. The impact of that, I can assure everyone that that would be worse than the impact of either Fukushima or Chernobyl. I'm not saying it's going to happen, but the NRC does not deny the fact, and Holtec does not deny the fact. They say that we guarantee it will not go critical as long as water is below 95% covered. Well, what about the total coverage? I think the words, reading between the lines, criticality is a strong possibility. Criticality is a disaster to Southern California.
Okay, this next question is a bit long and includes a lot of information, but stop me if you need me to stop and repeat. Okay, so at San Onofre, there are 123 high-level nuclear waste storage containers. They're all thin-walled steel temporary containers vulnerable to a corrosive marine environment 24/7. Everyone knows that metal situated near the ocean degrades quicker than it would elsewhere. Experts tell us that each canister holds the same lethal radioactivity as one Chernobyl event. Holtec has warranted these containers for only 20 years. Some canisters at San Onofre are already reaching the end of their design life and Holtec warranty. Someday, these canisters will need to be replaced and the deadly spent fuel repackaged into safer, thick-walled, longer-lasting casks. To do this, the San Onofre facility must have a spent fuel pool or a dry transfer facility, also called a hot cell. However, the California Coastal Commission gave Southern Cal Edison, which is the owner of the waste site and the manager of the waste site, permission to demolish the spent fuel pools as part of decommissioning. The Nuclear Regulatory Commission permits this. There's no plan B for a hot cell at San Onofre. Will they be able to retrieve the spent nuclear fuel to repackage it into safer containers without the spent fuel pools and without a hot cell?
Yeah, that was a long question. Let me just first talk about the thin-walled canisters. I mean, these are being used at 55 different sites in the United States. But again, San Onofre is lucky. It's right on the coast of the Pacific Ocean, where you have a very, very corrosive marine environment. That is going to accelerate the corrosion, and we don't know how much it's going to accelerate chloride stress corrosion cracking. It will do it. We know that some tanks in South Africa located near the corrosive water environment cracked within 17 years. Same material. The only difference is that the canisters at San Onofre are pressurized to 45 pounds, where the tank in Coburg was not pressurized, and 45 pounds is about 1.5 times what your tire pressure, and those are relatively high pressure. So what happens? What do we do if we have to deal with an accident or transfer that fuel or inspect the fuel or inspect the canister? I was this morning just looking at the technical specifications for San Onofre, and the only way they address it is if the cooling is blocked. The only remedy to that is unblock the cooling or lift it up and put it in a transfer cask to keep it cool, but it only considers one transfer cask. So your main question is, what do we do to move that fuel? And again, the NRC has a regulation that says the fuel must be retrievable. It's not retrievable. The NRC has ignored that regulation, and regulation is one sentence. It's a very firm sentence, and everyone's ignored it, and the NRC has looked the other way. So if we do have to retrieve it, you mentioned two different means, that is a spent fuel pool and or a dry cask to transfer it. Let's talk about the dry cask first. You and I have both recently read about dry cask or
Dry transfer.
dry hot cell transfers. We are talking billions and billions of dollars. They have never developed a hot cell that could handle a full canister. They have hot cells that'll handle individual 15 by 15 inch fuel elements, but not a whole canister. We're talking a phenomenal effort to even start the research. The only other alternative is the retention of the spent fuel pool. These devices are there. We have two of them. And should an event occur, we would have the ability to transfer that damaged fuel, damaged canister back into the spent fuel pool to keep it cool until we could come up with a way to take it back out, fix the problem, move it to a transportation cask, and then that's another problem, but I'm not going to get into transportation at this time. We are continuing to work very hard with the NRC to have it enforce its regulation for fuel retrievability. This morning, I looked at the legal technical specification, and all it says is if the air cooling gets blocked, remove the blockage or move it to a transfer cask. That is not satisfactory for me.
Thank you. Thank you. Okay, so God forbid there was a terrible accident. For example, the terrorist attack in the Ukraine at the Zaporizhia nuclear waste site. We know that that was weaponized. We know that several individuals died from the residual contamination. So God forbid something like this, or an earthquake or tsunami and flooding occurs. San Onofre has no plan B on site to secure the nuclear waste from public contamination. The NRC gave Southern Cal Edison off-site emergency planning exemptions so that they are not liable in the event of an accident. Why does the NRC permit this, and how does this affect off-site emergency planning?
Well, first of all, the NRC is not liable for anything. A recent NRC document, it was called New Reg 1864, that was issued 10, 12 years ago, talked about the consequences of a dropped fuel canister and its potential of breaching or leaking. And as you know, in 2018, San Onofre came very close to dropping the canister. That could happen, but the important thing about that analysis in New Reg 1854 is that if they did have a leak of the canister through any means, there would be radioactive material released from that one canister. And their analysis says in that new reg that the dose to the public residing outside of the perimeter would be 360 millirem. And I'm not going to explain at this time what it means, 360 millirem, but I want to put that in perspective. If we look at the emergency planning requirements in the regulations, it says that you must relocate people if their projected exposure is greater than 100 millirem. So their own numbers, they release and cause a dose to the people of 360 millirem, but in the regulations, it says we must relocate people if the dose is more than 100 millirem. So their justification for doing away with emergency planning is not science-based whatsoever. And their analysis only projects the dose. They stop their analysis beyond 1 mile. We don't know what the dose would be beyond that. And that's only the dose from a leaking canister. Is it going to kill anyone? No, but it will cause the evacuation, relocation of the people, and it will cause, by NRC definition, the declaration of a general emergency should one have a breach of the cask. Now, if that cask breaches right now as it sits there, we don't have any radiation monitoring to detect the radioactive material being released. If it's, just a breach due to corrosion, we will never know. They don't have the monitoring equipment.
So I've heard, sorry, I'm going off the questions, but I've heard that Southern Cal Edison at the songs or at the San Onofre waste site, they do have what has been coined 4 very, very sensitive Geiger counters, and it's in the parking lot, and it doesn't even measure anything going off site. What is your take on that?
My take on that is I used to be responsible for the radiation monitoring equipment at Millstone and the design of it, so I'm very familiar with radiation monitoring. And what you said, they're Geiger counters. Well, Geiger counters will only measure gamma rays and some beta. But if you look at the location versus the source of the radiation release, by the time it gets up there, and because it's hot air going up there, it's going to go up, straight up, because the normal ventilation path and the releases take it straight up. Even if they did have a significant release, it would not be detected by the radiation monitors that are located hundreds of meters away from the source of the release. What they really need is a technical specification to either put monitors on there or on a daily basis, check the radiation emitted from each individual cask. Not a big deal, but it's got to be done, but it's not required. Even though the regulations say it has to be monitored, it doesn't say how. Again, these are performance-based regulations, and they tell you what you need to do, but not how to do it.
Interesting. You can actually go to the SONG's San Onofre Nuclear Generating Station website, and they claim, and they do have monitoring and of their batch releases and etc. However, it's half. I've spent many hours there, and half of it is every column is not applicable, not applicable. So they are reporting, but it's very, there's no explanation for the public to understand that graphic, number one. And I think your explanation points to, we definitely need off-site monitoring in California. But on that note, how will,
Your
yes,
point on monitoring releases, those are liquid releases they monitor that they're discharging. It has nothing to do with the releases from the spent fuel storage system.
you're right, you're right. Thank you for making that clarification. How will Southern Cal Edison or the public know if there is a leaking canister?
Initially, they will not know. Those monitors will not pick up any, I want to say, significant release. They will pick up a very significant release, but a release of a few curies of cesium, krypton, xenon, there's no iodine, cobalt, will not be detected to those monitors. So there will be no pre-warning of imminent contamination of the area out beyond 1 mile. And as I said before, those monitors won't detect it because the heat from the canisters shoots those emissions straight up in the air, and then it comes down depending on the atmospheric conditions.
Thank you. How much and what types of radioactivity escape a properly sealed canister on a daily basis?
That's the easiest question you've given me. If they are designed as operated, there is no release from any radioactive material from a properly designed and maintained canister.
Paul, are you anti-nuclear or pro-nuclear?
That's an easy question. It goes back to my Navy training days. You know, in the Navy, they taught us, and they taught us well. They taught us about the risks, and they taught us about everything. And, you know, when I obviously was in the Navy, it was the safest thing I ever saw. When I transferred over to the civilian world, I saw the difference in design that, you know, they took a lot of shortcuts, but I still believe up until the late 80s that nuclear was safe. Now that I've seen how the Nuclear Regulatory Commission fails to regulate properly, makes the plants unsafe. So when you say, am I a pro-nuclear or am I anti-nuclear? Difficult question to ask. I'm anti-nuclear if the plants are overseen by the Nuclear Regulatory Commission, consistent to the way they've been operating over the last 15 years. I'm opposed to any reactor except Navy type reactors that are very robust, but I will never support a nuclear plant under today's license conditions and the fact that the NRC refuses to regulate properly. So I really call myself a safety advocate and stay away from the pro-nuke, anti-nuke label.
This is off the question, but it occurs to me, how is it that we've come so far from your training in the military and become so lax in the commercial nuclear generation of energy?
Oh, that's an easy question, and it's really economics. Nuclear plants are so robust and so expensive to build. If we ever had to build nuclear plants with the same requirements imposed on the Navy. Number one, they're now about 35% efficient, converting heat to electric power or propulsion. In the Navy, because of the robustness and the thickness of the walls and everything else and space allocation, those plants only operate at about a 15%. So if a land-based nuclear commercial plant was built per Navy regulations, it wouldn't be as efficient. It would cost probably 10 times as much. And even today, nuclear is not economically competitive. So we could not, and I don't care if you say it's a new reactor like San Onofre or a small nuclear reactor, you will find that if it's designed properly and regulated properly, it is never going to be comparable economically to the cost of other sources of fuel, especially solar and wind. And we've all seen what the economics are with that. And we have a long way to go. So am I in favor of any other new nuclear plants? Absolutely no.
Okay, so it all comes down to money in the commercial field is what you're saying. And that's possibly why the reason for the lax regulation.
That's true.
Okay. Changing course here. Would I die if I touch the side of a Song San Onofre nuclear generating system multi-purpose canister 37?
The quick answer is the dose rate, one meter away is about 35,000 rem per hour. That is pretty much a fatal dose. It's not an immediate death, but it's a long, slow, painful death. If you were up close to it for 5 minutes, you would, within weeks, suffer death. This is an exposed, unshielded canister, which no one in their right mind would go through. I mean, when they're in the ground and shielded, your dose rate is, certainly acceptable and meets the requirements. But exposing that cask to the air is fatal. Whether it's immediate or hours or weeks or days or years later, it's still fatal.
Okay. There have been numerous serious nuclear accidents in our lifetimes, but 4 really stand out. Santa Susana in Southern California, 3 Mile Island, Chernobyl, SL1 in Idaho, and Fukushima. What are the odds of an even bigger meltdown event in the future at a US power plant?
Well, if you take the odds, if you take the 400 plants that are in operation around the world, say an average life of 30 years, you come up with an accident. Well, hell, we've had at least one accident every decade. So the probability there, if you just look at all accidents, it's, for an individual plant, it might be 1 out of 10,000, all combined, it's much, much higher. But if you look, and in my opinion, giving any nuclear accident, and I'm not considering Department of Defense or anything like that, if you look at the 123 canisters and the potential for flooding and the consequences of flooding, my guess would be one of them will undergo a major failure sometime in the near future, within the next 100 years or so. I mean, we've got 123 of them. But if you get a flood, I think your chances are almost certainty of having a major accident on the scale of Fukushima or Chernobyl. I was an expert witness at 3 Mile Island. I saw what the lies were that the NRC was putting out I was in court. I testified. Uh, I've been through a lot in my young years.
And we're learning so much. While it is a low probability event, the criticality of multiple canisters could result in the relocation of millions of residents in Southern California. This is one more reason we need an analysis of external events required by NRC regulations. Do you think we will ever be able to remove the 3+ million pounds of nuclear waste from San Onofre?
Well, engineering people are really pretty good at coming up with unique solutions and, very, very creative. But from my experience in talking with other experts and reading things like from the National Transportation Safety Board on transportation and the recent thing we all read on dry cells, I personally don't know of any way it's ever going to move out of those holes at San Onofre. I just don't see the solution. I hope there's a way. You cannot even move those. You cannot possibly get them across Interstate 5. So for now, I don't foresee any way that they're ever going to be moved without some new revolutionary technology developed. But the other big stumbling block is public confidence. Public, and I'm contributing to it with the truth, that public confidence will inhibit a lot of actions that we really need to take on. And without public confidence, it's not going to happen. And the only way to get public confidence is to get people to put out the truth. And that's people like the Community Engagement Panel, Southern Cal Edison, the NRC, to open up and truthfully sit down, have a dialogue with us people, us questioning people. Hey, what about this? What about that? What are you going to do? And so on and so forth. And personally, I don't think that would be successful because they don't have an answer to the questions that I am answering.
And just to clarify, Paul refers to a dry cell, but what he's talking about is a dry transfer facility, otherwise known as a hot cell, which we are vying for as our last resort at San Onofre and several nuclear waste sites around the United States. And the reason for that is that the Department of Energy has left every nuclear waste site in a pickle. They promised to pick up the waste and take ownership of it and take it to a general repository. That is a failed promise. They kept the ratepayers and the taxpayers' money to fund this repository, supposedly in Yucca Mountain. There were not only political concerns, but very clear and present geological concerns. And so that project was given up. So every nuclear site is stuck with their waste, whether you're a nuclear power plant or a storage site, you're stuck with the waste because the federal government has no plan. This is why we are discussing these issues, hopefully to bring transparency and a good dialogue to the public. Paul, so finally, with all this in mind, where do we go from here?
Yeah, I just want to say that what you just said is absolutely true and very well stated. Where do we go from here? Number one is we've got to retain the spent fuel pools. This isn't going to help anything up at Humboldt Bay or Rancho Seco because they've already been taken away. And even if we retain the spent fuel pools for an accident, there's no way we're going to be able to stuff it all back in there. Where do we go from here? We've got to recognize the potential liability someone has, and I don't even know who that someone is, but it's billions, many billions of dollars. We've got to get out there and make the public aware of the problems. Everyone has a right to know what their areas are. I was just over in Pompeii, and I know what the risk is there. I can look up and see Mount Vesuvius, but I can elect or not elect to live there. You don't have that choice. You know, if Vesuvius is going to go again. So where do we go from here? We need, I believe, even if we get the spent fuel pools, we need a dedicated effort to come up with a hot cell to repair and transfer any fuel and inspect any fuel. That's step number one, but that doesn't solve all our problems, you know, such as the flooding. And if you damage 73 canisters, you might as well say, kiss your ass goodbye. I don't know, and it's very rare that I don't know something. But I haven't got a solution. If I had a solution, I would probably not be sitting at home doing things like this. It's one problem that I don't have an answer to. And the people in Southern California are going to be continually exposed to the potential release of significant amounts of radioactivity should a flood occur. Thank you.
Thank you, Paul, so much for your time. I want to clarify that Paul Blanch is working 100% pro bono, supporting the coalition of academia, political leaders, activists, and scientists here in our San Onofre safety advocate community. He is in no way, shape, or form being compensated for his knowledge today or his opinions. And we thank you for your time, and we thank you for sharing your experience with us today.
Oh, thank you very much, Kathy. I enjoyed it as always, and I look forward to our next session. You can stop the recording now.
Okay.